Hi guys, welcome. In this video, we'll explore how Python is revolutionizing the field of machine learning. By the end of this introduction, you'll understand why Python is the go-to language for ML and how you can get started. Python's combination of simplicity, a rich set of libraries and frameworks, makes it the best language for machine learning. Python's combination of simplicity, a rich set of libraries and frameworks, extensive community support, and powerful data handling capabilities makes it an ideal language for machine learning. Whether you're just starting with ML or building complex deep learning models, Python has the right tools and resources to support you. Why Python is preferred for ML. 1. Ease of use and readability. Simple syntax. Python syntax is clear and easy to read, which makes it beginner-friendly. This is important because ML involves complex concepts. And Python simplicity helps developers focus more on solving problems and understanding algorithms, rather than worrying about complicated code structures. Conciseness. Writing code in Python is more concise compared to many other programming languages, making it easier to implement machine learning algorithms. Two, comprehensive libraries and frameworks. Scikit-Learn. A powerful library for machine learning that provides simple and efficient tools for data mining and data analysis. It includes support for both supervised and unsupervised learning. TensorFlow and Keras. Popular frameworks for building and deploying deep learning models. TensorFlow is backed by Google, and Keras, which is built on top of TensorFlow, provides a user-friendly API. PyTorch. Developed by Facebook's AI research lab, PyTorch is widely used for deep learning tasks, and it offers dynamic computation graphs, which make model development more flexible. Pandas. A library for data manipulation and analysis that provides data structures like data frames to easily handle and clean data. Number PY. Used for numerical computations, it supports operations on large arrays and matrices, which is essential for data processing in ML. Matplotlib and Seaborn. Libraries for data visualization that help in understanding data patterns and relationships, which is crucial for model building and evaluation. Python is preferred for its large community support. Python has a vast and active community, which means you can easily find resources, tutorials, and solutions to problems. There are numerous forums, blogs, and platforms like Stack Overflow, where developers share their knowledge. Many researchers and data scientists prefer Python, leading to a steady influx of new libraries and frameworks tailored for ML tasks. Four, integration capabilities. Python can be easily integrated with other programming languages like C, C++, and Java, making it flexible for different ML workflows. It also integrates well with various databases and tools, enabling seamless data processing and model deployment in production environments. Five, rich ecosystem for data handling. Data is the backbone of machine learning, and Python has a rich ecosystem of tools to handle, process, and analyze large datasets. Libraries like Pandas and NumPy simplify the process of data cleaning and preparation, which is a crucial step in machine learning. Six, support for data visualization. Machine learning often involves understanding data patterns, relationships, and outliers. Python libraries like Matplotlib, Seaborn, and Plotly provide extensive capabilities for creating plots and visualizations, making it easier to interpret data and model results. Seven, extensive pre-trained models. Many Python libraries come with pre-trained models and tools for transfer learning, saving time and computational resources. Frameworks like Transformers by Hugging Face have simplified working with state-of-the-art models in natural language processing, NLP. Eight, good for prototyping and experimentation. Python's flexibility and the abundance of ML libraries make it suitable for quick prototyping. You can easily test ideas and iterate on your models. Interactive environments like Jupyter Notebooks allow for rapid experimentation and visualization of results in real time, making the model development process faster and more efficient. Nine, interactivity and data analysis. Using environments like Jupyter Notebook, developers can write code, run data analysis, and visualize results interactively. This interactivity is helpful when exploring datasets and testing ML models. Ten, widespread industry adoption. Python is extensively used in the industry for both ML research and deploying models in production. Its widespread adoption means that ML practitioners are more likely to work in a Python-based environment, making it a practical choice for a career in data science or ML. Eleven, compatibility with big data technologies. Python integrates well with big data frameworks like Apache Hadoop and Apache Spark, making it possible to perform ML tasks on distributed data. Twelve, support for cloud services. Many cloud platforms like AWS, Google Cloud, and Microsoft Azure offer built-in support for Python to create and deploy ML models. This makes it easier to scale ML applications and use cloud-based computational resources. Python is often used in academic research for ML and data science because of its simplicity and the availability of robust libraries. Many research papers and academic courses provide Python code snippets, making it easier to learn and reproduce ML models. Let's look at a basic example using Python. Suppose we have data about house sizes and their corresponding prices, and we want to predict the price of a house based on its size. We can use a simple ML algorithm called linear regression. Here's how it works with Python. We can use a simple ML algorithm called linear regression. Here's how it works with Python. Let's recall. Machine learning models work by learning from data. Here's a simple breakdown of the process. 1. Collect data. First, we collect a dataset. It could be anything, numbers, images, or text. 2. Prepare the data. Next, we clean and prepare the data, making sure it's in a format suitable for training. 3. Split data. Divide the data into a training set and a testing set, commonly 80% for training and 20% for testing. 4. Choose a model. We then select a model, such as linear regression for predicting house prices. 5. Train the model. The model learns from the data by finding patterns and relationships. This process involves adjusting parameters to minimize errors. 6. Make predictions. Finally, we use the trained model to make predictions on new, unseen data. Let's look at a basic example using Python. Suppose we have data about house sizes and their corresponding prices, and we want to predict the price of a house based on its size. We can use a simple ML algorithm called linear regression. Here's how it works with Python. Here is the Python code to implement it. This code imports the required libraries. The dataset for the application. Split data. Divide the data into a training set and a testing set, commonly 80% for training and 20% for testing. Train the model. The model learns from the data by finding patterns and relationships. This process involves adjusting parameters to minimize errors. Make predictions. Finally, we use the trained model to make predictions on new, unseen data. Once Python is installed, it can be used in interactive or scripting mode. Type idle, integrated development and learning environment in search box. This open Python in the interactive mode. Using print function, one can display a message. To work in scripting mode, select New File option from the File menu option. Let's paste the developed code. This Python code implements the steps of machine learning. Let's save the developed code. To run or test the developed module, select Run Module option from Run menu or press F5 key. Here is the predicted output, the price of the house with given size as input. Observe the dataset for house price for different sizes. Let's try predicting the price for other size house using the train model. It's working. Just observe with only few lines of code. An application using ML and Python is developed. This makes Python an ideal language for machine learning. This simple example shows how easy it is to use Python and Scikit-Learn for building ML models. With just a few lines of code, we train a model to predict house prices. Excited to learn more? Start exploring different types of ML models, such as classification for recognizing images or clustering for finding patterns in data. As you gain experience, you can dive into deep learning with frameworks like TensorFlow and PyTorch. Machine learning is an ever-evolving field with endless possibilities. Python makes it accessible to everyone, from beginners to seasoned data scientists. So, what will you build next? Thanks for watching. Don't forget to like, subscribe, and hit the bell icon if you found this video helpful. Drop a comment below if you have questions or suggestions for future topics. Happy coding! Wait! For my next video, Master Python for Machine Learning.